Okay, so what we were studying was the Maclaurin series. The first one, e raised to x, 1 plus x plus x square by 2 factorial plus x cube by 3 factorial plus so on. Then sin x, which is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. Cos x, which is
Sir, I
1.
think you're not sharing your
Sir,
screen.
your screen is not visible.
Sorry, there was a technical issue from my side. That's why I got disconnected. Anyways, so let's get back to the Maclaurin series. So first two series, e raised to x sin x, I have written. So e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Sin x is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial. So we have odd powers with alternate plus and minus sign. For cos x, 1 plus 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial and so on. And then sin h of x. So for sine hyperbolic, we don't have alternate plus and minus signs. So x plus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on. Cos h of x, the same thing, even powers but all positive. 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial, so on. Then tan of x plus x cube by 3 plus 2 x raised to 5 divided by 15 and so on. Tan h of x with alternate minus signs, x minus x cube by 3 plus 2x raised to 5 by 15 and so on. 1 upon 1 minus x, there's 1 plus x square plus x cube and so on. This is a very important series. Even in M3 you will need this. 1 upon 1 minus x, 1 upon 1 plus x. 1 plus x is with alternate plus minus signs, plus x square minus x cube and so on. Then log of 1 plus x, which is x minus x square by 2 plus x cube by 3 minus x raised to 4 upon 4 and so on. Log of 1 minus x, log of 1 minus x, which is equal to minus x square by 2 minus x cube by 3 minus x raised to 4 by 4 and so on. So everyone take a screenshot of this because we are going to need it for the next hour. And the last thing that we have seen was the binomial series. In the binomial series, I said that 1 plus x raised to n. So I can expand this even for the rationals. And the expansion was 1 plus n into x plus n minus 1 divided by 2 into x square plus n minus 1 n minus 2 divided by 3 factorial x cube and so on. So this is called the binomial series. We can use this. One example we have solved where we did expand the function y is equal to 1 plus x raised to x using log. Okay. Now we will go to the next example. Example, show that e raised to x cos x is equal to 1 plus x plus x square by 2 minus x cube by 3 minus 11 x raised to 4 by 24 plus dot dot dot. Is anyone, how can we get the series for this? No idea. There is Pratik.
Yes, sir.
How can we get the series?
Um, I'm trying to figure out. Not
Okay.
sure. Sir, maybe by taking logarithm
Can you
on both
simplify
sides.
by taking log? Daksh,
Yes, sir.
how can we get the series here?
Just trying, sir. Wait a minute.
So by taking the log on both side, maybe.
Hmm.
So by taking log both side,
Okay. What will happen if we take the log?
so cos 6, we have the series of cos x and ex.
You have y is equal to e to the power x cos
Sir, so it will be log y equals x cos x and cos x की series तो है हमारे पास.
log y is equal to x cos x. But then you will have to take e raised to something and then expand. Fine, that is also right. So we have the series x in bracket cos x. The series is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial and so on. Look, in show that there is a the things are up to x raised to 4. So I will take proper care that I don't go beyond x raised to 4. So what we have is log y is equal to x minus x cube by 2 plus x raised to 5 divided by 4 factorial, so on. So if I call this whole term as say z, then y is equal to e to the power z. So what I need to do is I need to expand e raised to z. Now y is equal to e raised to z. The series of e raised to z will be 1 plus z plus z square by 2 factorial. What is the first term in z? Z is of power x. Okay, power is x, and what by what power I need to calculate up to x raised to 4. So x square z cube by 3 factorial, I can write it down, plus z raised to 4 upon 4 factorial, and so on. Now let's put the value of z. If you are writing this down, please note it, and I'll give you a minute because I'm going to rub and then I'm going to write it down. X is to 5 by 4 factorial, z square 1 by 2. Then we will have the cube term, then we'll have plus x minus x cube divided by 2 plus x is to 5 divided by 4 factorial whole cube into 1 upon 3 factorial, which is 6, plus x dot 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 raised to 4. Look, in the last bracket, I'm just writing x because the next term is x raised to 3. And when I'm taking 4 brackets, x raised to 3, whatever you multiply by, it will become more than 4. And that's why I'm skipping the further terms. Because what calculations I need to concentrate on are just up to x raised to 4. Okay. So don't increase your work unnecessarily. Think up to what power you have to calculate and accordingly write down the terms. So constant term is just 1 throughout the series, which is the first one, 1 plus. Let's collect the coefficient of x. So in the first bracket, there is just 1x. In the second one, you are not going to get x because when you multiply this bracket with itself, the smallest power of x that you are going to get, that will be x square. So 1 plus x plus. Let's collect the coefficients of x square. In the first bracket, it is minus 1 by 2. For the square term in the second bracket, when x minus x cubed by 2, this will be multiplied to itself. X minus x cubed by 2, x raised to 5 by 4 factorial. So when this will be multiplied to itself with 1 by 2 as the coefficient, so what we will have, x into x, that is x square, 1 by 2 x square, right? Yes or no?
सर बट ये -1/2 कहाँ से आया?
First,
सर
oh,
वहाँ
there
पे
is
तो
no
x
x
क्यूब है.
square in the first bracket, yes.
सर x क्यूब है.
So what we have is simply 1 by 2, right?
Yes sir.
1 by 2 x square plus. Let's collect the coefficients of x cube. For x cube in the first bracket, we have minus 1 by 2. Then can we get x cube term from the second one? So if this term gets multiplied to the second one, we get x raised to 4. Okay. So the first will be x square. The next term we are going to get here will be x raised to 4. And if you look at the next term, you will get x raised to 6. Okay. So there is no x raised to 3 term in the second bracket. So what we will think of is x raised to 3 in the third one. What is the third term when you make the cube? So when we make the cube, so what we will have, x minus x cube divided by 2 plus x raised to 5 divided by 4 factorial, so on. Now x cube, how I am going to get it? When this x will be multiplied to this and this. When these three terms will get multiplied, I'll get x cube. No other way I can get x cube. So when these three terms are multiplied, the coefficient will be 1 by 6 plus 1 by 6 x cube. In the fourth term, you cannot get x cube because the first power will itself be x raised to 4. So this will be minus 3 plus 1, 2 by 6, which is 1 by 3. Yes, that's that. Plus. Now let's collect the coefficients of x raised to 4. In the first bracket, there is no x raised to 4. In the second one, can you get x raised to 4? Yes. So if I'm multiplying just these two things, for x raised to 4, how I'm going to get it? X into x cube. So that will be minus 1 by 2. And don't forget that there is outside 1 by 2 there. So that will be minus 1 by 4. And the other one, when this first term will get multiplied to the second term will get multiplied to the first one. Again that is minus 1 by 2 and outside minus 1 by 2 plus 1 by 2 minus 1 by 4. Is it right? And then in the third one, there won't be x raised to 4, or will it be? So when these three brackets are multiplied, there is no way that you can get x raised to 4. So if you take the first one, first one, first one, so you have x cube. When you will multiply the first one to the first, and there is no x square then. So you won't get x raised to 4 in the third bracket. So I'll think of the last one. And the last one, there is 1 upon 4 factorial, which is not to be forget. So when first term will be multiplied of each of the brackets, so we'll get x raised to 4. So we have plus 1 by 4 factorial, which is 24 x raised to 4, and so on. So simplifying the series, 1 plus x square by 2. So if you simplify this, minus 3 plus 1, which is minus 2 by 6, which is minus 1 by 3 x square. Sorry, x cube, minus x cube by 3, plus, to simplify this, minus 1 by 4, minus 1 by 4, which is minus 2 by 4, minus 1 by 2. So minus 1 by 2 plus 1 by 24, minus 22, 48. So that will be 11 by 24. This is minus 11 by 24 x raised to 4. Clear? Look, simplifying a series is quite difficult until and unless it is a subjective paper. You won't have to deal with this difficult show that. But if it is online, so you must be at least be able to take square or cube, collect the coefficients of x cube and so on. Because the question can be uh, in the Maclaurin series expansion of e raised to x cos x, what is the coefficient of x cube? So you should be able to do that. Let's see if you can solve this. Expand under root 1 plus sin x up to x raised to 6. You have 2 minutes. It's a very simple example.
सर
Hmm.
वन को cos स्क्वायर एक्स बाई टू प्लस साइन स्क्वायर एक्स बाई टू लिखना
Hmm.
एंड साइन एक्स को टू साइन एक्स cos x, so it will be cos x by 2 plus sin x by 2 का square under the root.
Very good.
So cos x by 2 plus sin x by 2 we can use individual expansions.
Yes. So sine square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. So this will be under root sin x by 2 plus cos x by 2 whole square. So this is simply sin x by 2 plus cos x by 2. So the expansion of sin x by 2 is x by 2 minus x by 2 square, oh sorry, cube upon 3 factorial plus x by 2 raised to 5 upon 5 factorial. Next power is x raised to 7, so I will leave it, plus 1 minus x by 2 square upon 2 factorial plus x by 2 raised to 4 upon 4 factorial minus x by 2 raised to 6 upon 6 factorial and so on. So you add it and you will get the series. But you have to simplify it. Look, I haven't simplified. I have stopped here. Fine. Next example. It is a bit different one now. So prove that. Example. Tan inverse of x is equal to x minus x cube by 3 plus x raised to 5 by 5 x raised to 7 by 7 and so on. Yes. Any ideas? Okay, I'll give you a hint. Try to use derivatives. Okay, so y is equal to tan inverse of x. So dy by dx will be d by dx of tan inverse x. We know that derivative of tan inverse of x is 1 upon 1 plus x square. So what is the series expansion of 1 upon 1 plus x square? So 1 minus of x square plus x square square minus x square cube and so on. This is nothing but dy by dx. What you want? You want y. Remember this. So 1 minus x square plus x raised to 4 minus x raised to 6, so on. So now integrating, y will be equal to integration 1 minus x square plus x raised to 4 minus x raised to 6 dot 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 dx. So this will be x minus x cube by 3 plus x raised to 5 divided by 5 minus x raised to 7 upon 7 and so on. Add this series in your list. Tan inverse of x is equal to x minus x cube by 3 plus x raised to 5 by 5 minus x raised to 7 upon 7, because in substitution examples we will be using this. Can someone tell me which series does this look like? It looks like which series?
सर tan inverse hx मतलब tan h inverse x.
We haven't written it, right? Tan x inverse. From the
So we
existing,
wrote it in the last lecture.
okay. So we can see that the sin x series, if you relate, sin x and this both are almost similar. Just one change is there, that in sin x there is a factorial. I mean 3 factorial, 5 factorial, 7 factorial is there. Whereas in tan inverse x, factorials are not there. There's simply 3, 5 and 7. Okay. Next example, expand sin inverse of x in ascending powers of x. Y is equal to sin inverse of x dy by dx is 1 upon under root 1 minus x square, which can be written as 1 minus x square raised to minus 1 by 2. So Pratham, how can we go ahead?
So we'll take log on both sides. I guess.
You will take log of dy by dx. It won't
N-
be a
No,
convenient
sir.
way.
Sorry, sir. I guess we'll take binomial of the 1 minus x square.
Yes, binomial series we can take of this 1 minus x square, and that will be 1 plus n. What is the value of n here? It is minus 1 by 2, which is, then there is minus of x square plus minus 1 by 2 minus 1 by 2 minus 1 divided by 2 into minus of x square whole square plus minus 1 by 2 minus 1 by 2 minus 1 minus 1 by 2 minus 2 divided by 3 factorial, which is 6, that is minus x square cube, and so on. So this is 1 plus x square by 2 minus 1 by 2, and this will be minus 3 by 2. So minus minus will become positive. Minus x square whole square is again positive. So this is 1 into 3 and divided by 2 into 4, x raised to 4, plus, again this is minus minus minus. 3 minus signs are there, and minus x square ka cube will again give minus sign, so minus sign gets removed. And what we have is 1 by 2, and this will be 3 by 4, and this will be minus 5 by 4. So totally what we have, 1 into 3 into 5, the denominator, first ka 2, second ka 4, and there is already 6 x cube, so on. This is dy by dx. So what do we have? Y will be equal to x plus x cube divided by 6 plus, we'll have 1 into 3 x cube, 4 4 16, we will have 4 6 4 4 16 will get cancelled out, 2 4 5. So we'll have 3 into x cube upon, totally we will have 40. Or easy to remember, what I can write it down here is,
Sir, x raised to 5.
x raised to 5, sorry, x raised to 5 upon 2 into 4 into 5 plus dot dot dot. This is x raised to 6. Okay. So in the similar manner, you can find out the series for cos inverse. You can find out the series for cot inverse, sin h inverse, tan h inverse. Okay. So we have first type, we have seen that the series can be found out using substitution. I'll just recall what we have done. First, we saw the examples using substitution where we substituted the series. The second one we have seen using derivative. Also, you can use the integration. I'll put one example in the tutorial where you can find out the series using an integration. Third, now we'll use the third type where you are going to use this again by an example. Prove that tan inverse of under root 1 plus x square minus 1 divided by x is equal to 1 by 2 in bracket x minus x cube by 3 plus x raised to 5 by 5, so on. Any ideas?
Derivatives.
No.
Or then substitution.
What will be the substitution?
X equals tan theta.
So put x is equal to tan theta. Okay, so let's y is equal to tan inverse of under root. Let's what there's no need of this y is equal. So consider y is equal to tan inverse of under root 1 plus x square minus 1 upon x. So put x is equal to tan theta. So what we have is tan inverse of under root 1 plus tan square theta minus 1 upon tan theta. So if we simplify this, we'll have tan inverse of 1 plus tan square theta is sec square theta. So sec theta minus 1 upon tan theta. So if we simplify this, tan inverse of 1 minus cos theta upon sin theta. So which is tan inverse of 1 minus cos theta is equal to 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2. So the final answer is y is equal to tan inverse of tan theta by 2. So in a particular domain, tan inverse and tan will get cancelled out, and what we have is 1 by 2 times theta. What is theta? And theta is equal to tan inverse of x. So y is equal to 1 by 2 tan inverse of x. We have the series of tan inverse of x, which is x minus x cube by 3 plus x raised to 5 by 5, so on. Okay. Hmm. Example, expand cos inverse of x minus x inverse upon x plus x is inverse in ascending powers of x. Okay, anyone? What is the answer?
Substitution in this.
What is the substitution?
X equals cos theta.
Yes. Like first we'll take the x inverse, like we'll write it by like x minus 1 by x upon x plus 1 by x. That will become
Hmm.
cos inverse x square minus 1 upon x square plus 1. Then we'll substitute x as tan theta.
X is tan theta. So final series is
Sir, cos theta, na? X is cos theta.
no, x is tan theta.
It will become like y is equals to cos inverse tan square theta minus 1 upon tan square theta plus 1.
So minus
1
sign
plus
can
cos 2 theta.
Yes, it will become cos inverse minus cos 2 theta.
hmm. So minus cos 2 theta is, so I consider that everyone has come up to this cos inverse of minus cos of 2 theta. So this is cos inverse of cos phi minus 2 theta, right?
Yes, sir.
Hmm. So this will be phi minus 2 times tan inverse of x. Okay. So one example you can try just prove that e raised to x cos of x is equal to 1 plus x minus x cube. Oh, sorry. Let's not take this. I'll give you another one. expand log of sin x upon x in powers of x. Try this.
Sir,
Yes, Pratik.
um, I did it like this. First I separated them. So log of sin x minus log of x.
No, no, not that way. You won't get the answer. You will get log x in that series, right?
Yes, so log x can be written as 1 log of 1 plus x minus 1.
Just a minute. Log x you can write as.
Log of 1 plus x minus 1. And it can be substituted in log of 1 plus x series.
Acha. And how you are going to do this? Now log of
1 plus
1
x.
plus in bracket x minus 1. This is how you are going to use it.
Yes.
But then in the series, at the place of x, you will have x minus 1. You won't get the series in powers of x. Am I right?
Yes, but it can be expanded too, right?
But up to what you will expand, na?
Yeah,
So
yeah.
in every term, there will be 1 as well as x.
Okay.
So you don't get an expansion in powers of x there. Are you convinced?
Yes, sir. Yes, sir.
Uh, no one? Okay, I'll tell you. So log of 1 plus sin x I can write as x minus x cube by 3 factorial x raised to 5 by 5 factorial so on upon x. So this will be log of, I can take x common from the numerator and in bracket what I get 1 minus x square by 3 factorial plus x raised to 4 upon 5 factorial minus x raised to 6 upon 7 factorial so on. You have denominator x. So this 2 gets cancelled out here. What we have is log of 1 plus in bracket minus x square by 3 factorial plus x raised to 4 by 5 factorial minus x raised to 6 upon 7 factorial, so on. Now I think you can go ahead and give me the series expansion of this up to x raised to 6. Please do it. If you don't do it yourself, you won't be able to do it later. So try it. Anyone?
So minus x cubed by 6 plus x to the power 4
Just,
by
just,
120.
just a minute. Huh? Let me just verify. Yes, tell me.
Minus x cubed by 6 plus x to the power 4 by 120 minus x to the power 6 into 1 by factorial 7 plus 1 by 72.
Okay. Minus 1 by 6 is correct. X raised to 4 coefficient 1 minus 1 upon 180 is correct. So the last coefficient you can multiply and the final answer will be 2835.
Yes, sir.
Yes, Sarthak, you are right. Fine. At this stage, our Taylor and Maclaurins is over. In the next lecture, what we need to do is we need to start with the new chapter. I was thinking of starting it today, but due to some issues, I couldn't start. So in the next lecture, we'll start with the new chapter. Our more than 50% syllabus is over, so you can start studying. Soon you will be having midterm, and as soon as you are done with midterm, you will get a notification about the end term too. So keep practicing. I'll give you the notes about successive Taylor and Maclaurin series, and also as our topic is completed, I will upload the lectures too. Any issues? One thing I wanted to ask, Daksh. Daksh, are you there? No.
सर उसका माइक काम नहीं कर रहा, मैसेज आया।
Yes, sir. Yes, sir.
Okay. Uh, where's Pratik? Pratik आपसे
Yes, sir.
ये डोनाल्ड ट्रम्प हमेशा आता है अपने मीटिंग में इन एवरी
No,
टाइम?
sir. No, sir, वो एक्चुअली लाइक नाम बदल के आते हैं कुछ लोग, लाइक हर लेक्चर में कुछ अलग नाम रहता है और गाना बजाते हैं। आई डोंट नो कहाँ
Okay,
कहाँ कहाँ से तो लिंक
some
मिलती है।
students are there. I mean, in almost every lecture, this kind of thing is there because it
Yeah,
happened for the first time in my lecture.
yeah, but in other lectures too, it has happened a lot.
Okay, fine. ठीक है. In the next lecture, you will get a link on your email, and using that only you can join. So by that way, we can exclude this kind of possibilities. And we will have our tutorial in the next lecture. On the Saturday lecture, we can conduct the tutorial on successive Taylor and Maclaurins. Fine. Thank you, everyone.
Thank
Thank
you.
you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
थैंक यू सर।
Thank you, sir.